So here is section D, part 2, questions 11 and 12. So 11 and 12 kind of go together. So we're going to put them all in one video. So it says, how many moles of argon are in 30.6 liters at 28 Kelvin and 658 millimeters mercury of pressure? Question 12 then asks you to use your answer from 11 to determine the grams of argon found. So the thing here is that since we see moles, we know that we have to use the ideal gas law. So PV equals nRT. So we have pressure, volume, moles, gas constant, and temperature. We're going to need at least 4 of the 5. The easiest one is always that gas constant, 0.0821 liters ATM per Kelvin mole. It's asking us to find the number of moles. How many moles of argon? It gives us the volume, 30.6 liters. It gives us the temperature, 28 Kelvin. And it gives us the pressure is 658 millimeters of mercury. So before we plug in, the thing we should always do is check those units to see if they're able to be plugged into that ideal gas law. However, our pressure, millimeters mercury, does not match up with our ATM, so the first thing we're going to have to do is convert millimeters of mercury to ATM. So to do that, we're going to say 658 millimeters mercury. Millimeters mercury up top means it's going to the bottom. ATM is going up top. So 1 ATM is equal to 760 millimeters mercury. Those units cancel. You plug it in. So we will say 658. 658 times 1 divided by 760. And we get 0.866 ATM. Awesome. So let's go ahead and rewrite that. ATM. Perfect. So now that it's all set up, we're good to plug it in. Before we do that, I always like to manipulate the equation so that we don't have to worry about those numbers getting shuffled in transition. So since we're solving for n, let's go ahead and isolate n from the start. So we're going to divide both sides by r and t. Cancels. We rewrite it PV over RT is equal to n. So now we can just go ahead and plug it in. Our pressure is 0.866 ATM. Our volume is 30.6 liters. Our gas constant, liters ATM per Kelvin mole. And our temperature is extremely low. Let's plug it on in. 0.866 times 30.6, close parentheses. You always need parentheses around the tops and bottoms. Divided by open parentheses for the bottom. 0.821 times 28, close parentheses, hit enter. We get 11.528 moles of argon for this problem. So this is your answer for number 11. But number 12 asks us to take it just one step further and figure out how many grams are in there. So at that point, it just turns into a basic stoichiometry problem. So we're going to say 11.528 moles argon. Moles of argon. Grams of argon. So 1 mole, we check our periodic table. The molar mass of argon is 39.95. Plug it in, moles cancel, and we'll say 11.528 times 39.95, 460.54 grams of argon. So that is your answer for number 12.